We're back again. Still don't know what I want to say at the start of every video, so we're gonna need to brainstorm that. But we are back again. This is hopefully the first video you guys are watching at home, so I can't wait to hear how that goes. But if the technology didn't get all sorted out, then we're watching it in class. So hi, I'm probably waving back. Hi. Okay, super fun. So this is also the first video that you are watching that is after some of the feedback I got from you guys. So again, I'm so open to feedback. These notes are for you guys, so if there's something that you would like to see or other things that you would like to add on or do with these videos, I am all ears. So make sure you come see me about that, okay? So the title of today's lesson is No Real, One, and Infinite Solutions. No real, one, and infinite solutions. So this is kind of a add-on to the last lesson we did, so it'll be a quick one. Alrighty, and let's open to a new page. Let's see here. Perfect. I kind of miss all the bloopers here. Now that I know how to set up my doc cam, there's no wasting time. Alrighty. Unit 1, Lesson 4. We're looking at no real, one, and infinite solutions. Alrighty, so these are going to apply when we have variables on both sides. So when solving equations, it is possible for the variables to cancel out when they're on both sides. So when solving equations, hi, I'm recording a video, say hi.
Hi.
Hi, it's our custodian Lane.
Yeah, what's up?
Not much, we're just doing some online notes.
Some online notes?
Yeah, well, yeah, I mean, they're like recorded notes. They watch them at home. It's like their new homework. They like watch them at home, and then we do the worksheets in here. It's like part of the flipped classroom.
What?
I know, right?
That sounds like so much fun.
It is. Okay, well, I'm going to get back to it. Thank you. When solving equations with variables on both sides, you never know what's going to happen in these videos, you know? It is possible, anything is possible, it is possible for the variables to cancel out. When using the properties of equality. Quit laughing at me. I'm closing my door next time. Okay, so I'm going to read that again since we got a little choppy there. So when you're solving these equations, you've got variables on both sides. It's possible for these variables to cancel out, and we're going to look at what happens when those variables cancel out. So if the variable cancels out, and the statement, so whatever you're left with, the statement is false, the equation has no real solution. So let's look at an example. 3 parentheses x plus 4 is equal to 3x plus 11. I should instantly go to the parentheses. We're going to use that distributive property. And I'm simplified to 3x plus 12 is equal to 3x plus 11. Next thing I want to do is tackle those variables. So I'm going to subtract 3x from the side because I want to eliminate it on that side. But when I subtract it on the other side, it completely cancels out. So what I'm left with is 12 is equal to 11. This is that statement I was referring to in our definition. Is 12 ever going to be equal to 11? I sure hope not. So that's going to be a false statement. So our solution is no real solution. If you guys have older siblings, maybe they've talked about learning about imaginary numbers. We'll talk about that a little bit more in class, but that's going to be higher level. But at this level, it's important to know that they aren't real. So now let's see what happens when it's true. Hint, it's in the title. Alrighty. If the variable cancels out, I can spell, kinda, and the statement is true, the equation has infinite solutions. Here's an example. 2 parentheses x plus 7 is equal to x plus 14 plus x. Hopefully you see the eyes instantly go to the parentheses. Maybe some of you are looking to combine those like terms. I'm going to do it all in one. So here we go. 2x plus 14 is equal to 2x plus 14. Miss Hardawig, if I can tell at this point, can I stop there? Sounds good, but I'm going to keep going. I'm going to subtract 2x on one side, and when I do that to the other side, I see that 14 is equal to 14, which is always going to be true. So I would write that this is an infinite solution. This problem right here has infinite solutions. Alright, so let's take a second and kind of talk about why this is the way that it is. For starters, I want to remind everybody that variables represent numbers we don't know. Before this lesson, okay, we found the exact solution. So when you found that x was equal to 4, that was its only solution. That was it. We stopped there. Okay? Now, with these, it opens the door to that we can see that the variables can represent infinite amounts of numbers and no real numbers. Parentheses, solutions. Okay? So this is another type that we are going to see. We're going to try these. Try these 3 on for size. I'm going to write all 3 examples down, and then you'll have, oh my gosh. Miss Hardawig, push your notebook up. Thank God I looked at the screen because I was going to keep going and then none of it would have been recorded. Okay, so now I'm going to write the 3 examples, and you can pause the video, try them on your own, and then watch them, watch me solve them for the remainder of the time. But if you wanted to just look at all 3 and kind of compare them, Our first example is going to be negative 2 parentheses x plus 3 is equal to a negative 6 minus 2x. Example number 2 is 3x plus 15 is equal to 2x plus 15. And then example number 3 is x plus x plus x. Oh my gosh, are we talking about Taylor Swift here? Jesus. Gosh, I'm so lame. Okay, minus 5 is equal to 7x plus 5 minus 4x. So you can pause now. Welcome back. Time to start solving. We're going to start with the distributive property because our eyes are instantly going to go to those parentheses. I'm going to have negative 2x minus 6 is equal to negative 6 minus 2x. I want to tackle my variables first. These are negative. I'm going to add them to both sides. Those are going to cancel out. And I have negative 6 is equal to negative 6, which is always going to be true. So this is infinite solutions. I apologize for my cursive. I will try to write and print more. It's just more natural to me. Alrighty, example number 2. We have 3x plus 15 is equal to 2x plus 15. I'm going to subtract this 2x first, so that's going to cancel out. 3x minus 2x is 1x, so 1x plus 15 is equal to 15. Subtract 15 from both sides because I want to get that variable by itself, so I have x is equal to 0. This is a 1 solution. 0 is a solution, okay? Don't forget. So just because you get 0 doesn't mean it's a no solution, okay? 0 is a solution, so be careful. And then last but not least, we've got 3x's minus 5 is equal to, when we combine those, we have 3x plus 5. When I eliminate my variables here, I have negative 5 is equal to positive 5. Negative 5 and positive 5 are not the same number, okay? So this is a no real solution. I love to do stuff like this. I really try to trick you here, okay? Make sure you're paying attention to your signs. And that is it. See you tomorrow.